So welcome to our discussion topic of the day. We are going to talk about alkali earth metals. We've already talked about alkali metals. You can check it in the video below this. So what are alkali earth metals? So these are elements that belong to group 2. How do you identify them? You check the number of electrons in the outermost energy level. Now in this case, you can see beryllium has 2 electrons in its outermost energy level. This one, magnesium also has 2, and calcium has 2 electrons in its outermost energy level. So let us look at the ionic and atomic radius. So we say the atomic and ionic radius increases down the group due to an increase in the successive energy levels. As you can see here, in beryllium we have the first energy level. This is the first energy level, and the second energy what? The second energy level. Now when you go to magnesium, you have the first, second, and you have what? The third. Calcium, you have first, second, third, and fourth energy level. So you can see that as we go down this group, we keep on adding another energy level. So this increases the atomic radius, okay? So let me draw here one. So for example, we're going to draw for beryllium. So we have 2 energy levels with 2 electrons. You can put there, we can put here, okay? And then let us draw for calcium, or even let's just draw magnesium in this case. So we have magnesium, the first energy level. We have the second energy level here. And we have the third energy level. So you can see the distance between, or the distance from the nucleus to the outermost energy level. That is our radius. As you can see, the radius is doing what? It is increasing from beryllium to magnesium, meaning it's also going to increase when you go to what? To calcium. So that is the atomic radius. Now when you talk about ionic radius is formed when you're forming an ion. So during the formation of an ion, we normally lose 1 electron, and we normally lose the 2 electrons in the outermost energy level. So if you're going to draw the ion of, so this is the atom. So this is our atom. This is the atom of beryllium. So if you're going to draw the ion of beryllium, we're only going to draw beryllium with how many energy levels? 1 energy level, okay? Because during the formation of an ion, we lose these electrons in order to attain what? Stability. So these compounds lose the last energy level, the electrons in the last energy level during formation of an ion. This in turn decreases the distance between the nucleus to the outermost energy level, meaning that the ionic radius of group 2 elements are smaller than the atomic radius, okay? This is the second point. Now let us go to ionization energy. Now what is ionization energy? We say this is the minimum energy required to remove electrons from the outermost energy level of an atom in its gaseous state. Now these elements lose the 2 electrons in order to attain stability, meaning we are going to have the first ionization energy. We're going to have the first ionization energy and the second ionization energy. So we are not going to lose all the electrons just like that. No, we are going to lose them successively. To turn out, we're going to start with the first one, the first electron, and then we're going to proceed to the second electron. Okay, now what is the trend in ionization energy before we come to these 2 points? So ionization energy is going to decrease down the group due to an increase in the atomic radius. Remember we said things or the factors that affect the ionization energy in an atom, we talked about it in alkali metals. We say the factors are 1, the distance between it is the distance between the nucleus to the outermost energy level, because remember we are losing these electrons in this outermost energy level. So if the distance increases, then it means these electrons that are outside, that are far from the nucleus, are going to be loosely held. Thus, we're going to lose them easily. Another thing is something that we call the shielding effect, okay? So we said these electrons which are outside here, they are loosely held. This is because these other electrons in the respective energy levels, or the other electrons which are closer to the nucleus, are shielding the electrons which are far from the nucleus from getting the what? The full nuclear force of attraction, or the full nuclear charge, which is responsible to holding the electrons together in an atom. Okay, so now let us talk about the first and the second ionization energy. What happens and what is the first and the second ionization energy? So we're saying the first ionization energy is responsible to or of removing electrons from a neutral atom. So for example, here we have magnesium. Magnesium, we're saying from a neutral atom. Why are we talking about a neutral atom? This is because in an atom, the number of protons and the neutrons are the same. Okay, so the number of protons and electrons are the same. So if the number of protons are 7, in this case, let us just talk about magnesium. So if the number of protons in magnesium are 12, then it means the number of electrons are what? Are 12. These protons are the ones which are positively charged and electrons are negatively charged. So the charges like cancel each other. So we say an atom is neutral in charge. Okay? Now, but an ion, on the other hand, of our metals or of our alkali earth metals are going to be positive in charge. So the first ionization energy is responsible of removing the first electron from our neutral atom. So if you're talking about magnesium here in this case, we're going to say magnesium is going to lose the 2 electrons, and we said they lose the 2 electrons one at a time. So how are we going to write this equation? So the equation is going to be like this, or how are we going to represent that? It's going to be magnesium. Okay, that is our magnesium, and it is solid. During the formation of an ion, we even wrote these equations. We're going to form what? Your magnesium ion. We're going to put there a positive charge, because now we have acquired a positive charge because we've lost 1 electron. Okay, so we're going to form magnesium ion. Okay, that is our product, plus now the electron that we were losing. So the first ionization energy, or the energy required to lose this first electron, is going to be 736 kilojoules per mole. Okay, now we are going to remain, so we have lost the first electron. So we are remaining with 1 electron here that we need to lose. So for us to lose this electron, now we are going to use this second ionization energy. So the second ionization energy is responsible of removing electrons from an ion with a single positive charge. So for us to remove this electron, we are going to use the second ionization energy, and we are going to form an ion with now a positive charge, or a +2, or with a charge of +2. So we are going to take this. Remember, we formed this. Okay, that was our product. So we are going to have this magnesium ion, the one that had the first, we lost the 1 electron, so we had 1 electron in our outermost energy level. Okay, so that's why we're writing it as magnesium ion. So these are the steps. This is the first thing that is going to happen, and then the second thing is this. So you have a magnesium ion forming a you have a magnesium ion which has a single charge, a single positive charge, forming a charge of +2 of forming a charge of what? +2. And we've said the second ionization energy is going to be stronger or higher. So let us write here, it is what? It is higher than the first ionization energy, meaning the energy that is going to be used in removing the second electron in the energy level is going to be 100, and it's going to be 1450 what? Kilojoules per what? Per mole. So that is the first and the second ionization energy. So another thing that we need to talk about, or we should mention, is the melting and boiling point. Remember, these are metals. So metals have a metallic bond between them or among them. So this means the metallic bond is a very strong bond that requires a lot of heat energy for a metal or for these compounds to do what? To break. Thus the high melting and boiling point. Maybe another thing that we can talk about is conductivity. So alkali earth metals are better conductors of electricity compared to alkali metals or compared to group 1 element. Why is this? This is because these alkali earth metals have more, or they contribute to electrons or to delocalized electrons compared to alkali metals which contribute only to one with a single delocalized what? Electron. Another thing is that maybe we can say is once an electron has been lost from an atom, once we have lost an electron from an atom, the overall positive charge is going to remain, and the electrons that are remaining now are going to be firmly held. So these electrons that are remaining after we have formed now our ion. So after we have formed our ion, these electrons that are going to remain here, these electrons that are going to remain here after we have formed our ions are going to be tightly held. And this is because we have reduced the distance from the nucleus to the outermost energy level. Thus, the nuclear force of attraction becomes stronger. Okay? So, meaning when you're continuing even to lose, that is why you can see the second ionization energy, it normally is higher, because once you lose the first electrons, the electrons which are remaining are going to be tightly held. So you're going to require a lot of energy to remove the second one. Okay, so when you come to the properties of these compounds, we say they are metals just like group 1. So we're going the metals reacting with water to form metal hydroxide plus hydrogen, metal plus oxygen to form your metal oxide. You have your metals plus halogen to form metal halides, metal plus acid to form your salt and hydrogen gas. Another unique thing that I would want us to talk about is the reactivity of magnesium with water. So we say magnesium reacts slowly with cold water, okay? But it reacts readily with steam, okay? So that is one thing that you also need to always remember. Magnesium reacts slowly with cold water, but it reacts readily with steam. So when you react magnesium with cold water, this is a metal. We've said metal plus water, you form your metal hydroxide plus hydrogen gas. But when you react your magnesium with water, you're going to form your magnesium hydroxide plus your hydrogen gas. But when you react your magnesium with steam, because we've said it reacts readily with steam, you're going to form a metal oxide, okay? You're going to form your metal oxide plus hydrogen gas. So this one with steam, when you react magnesium, let me come here. When you react magnesium with steam, you form a magnesium oxide. I've said you're going to form a magnesium oxide and hydrogen gas. Okay. This is the steam. But if you react it with cold water, it's going to be a very slow reaction. You're going to form magnesium hydroxide plus hydrogen gas. So another thing that is unique, it's also the reactivity of what? Calcium. So how does calcium behave as a group 2 element? So we say the first thing is calcium, when you react, we have said the reaction between a metal and an acid forms salt and water. But now when you're talking about calcium, as a metal, and the reactivity between calcium and sulfuric acid. What is going to happen? You're going to see that your calcium reacts the reaction is going to be very quick, okay, but it's going to stop also. The quicker it starts, the faster also it stops. So the reaction is quick, but then it comes to an end, it stops. And why does the reaction stop between calcium and sulfuric acid? This is because there is going to be the formation of an insoluble sulfate when calcium reacts with what? Sulfuric acid. Remember, we are going to form a salt that is what? Calcium sulfate. So calcium sulfate is going to be formed, which is going to be an insoluble salt. So we are going to have the precipitation reaction occurring, and the reaction is going to stop immediately. Another thing that we need to talk about calcium is, other than the reactivity with acids, we say that when you react calcium, this calcium, yeah, when you react calcium with chlorine, now the reaction between a metal and a halogen, chlorine is a halogen, so we're supposed to form a metal halide, and we say this is called direct synthesis. So when you react your calcium and chlorine, you may there may not be we are going to have a reaction that is going to be, we are not going to have a steady reaction due to the formation of a coating of calcium oxide. So when calcium and chlorine reacts, the reaction is not going to be fast, it's going to be slow, and you're going to form, this is because there's going to be a formation of calcium oxide that is going to be formed. So calcium oxide is going to be formed first when the metal is going to be hit, because remember, the reactivity between a metal and a halogen, we say it's direct synthesis, and it is where we are going to mix these two elements and then we're going to hit them strongly. So when you're going to mix them and hit them strongly, calcium is going to react readily with oxygen that is in the atmosphere or in the air, and you're going to form a calcium what? A calcium oxide, which is going to be insoluble. So the coating is going to prevent further reaction between our calcium and our chlorine or our halide. So those are the properties and the reactions and everything that you need to know under alkali earth metals.